Okay, so I'll start off the session. Before I begin, thank you for each and everyone who's made time to join us on this inaugural session of Learning Twice, which I hope will be an effective use of the Saturday evening time that you have sacrificed on this behalf. But my intention was purely a knowledge sharing and thought sharing forum where we can share each other's learning in AI. And for whatever reason, whether you are here, itself proves that you are all equally excited about artificial intelligence like I have been. Most of the names here have known me. I have either been a part of your earlier office workforce, working with you as a um, colleague or studied with you as a part of either some course, or in this case, most of us here are also with ISB, where I have hopefully cleared my new certification in artificial intelligence. And in that regards, I must thank Lalit sir, who's been guiding us like a stalwart in that domain, who's also joining us today. So for all those people who are a part of that ISB course, I don't need to introduce Lalit sir on that regards. But for all the others, I would just like to give a quick introduction about myself for those names who don't know me yet. And then I can also give a quick overview of this Learning Twice initiative before I get started. So I'm Sri Harsha, and I have close to around 18, 19 years of corporate experience, primarily working in the marketing and analytics space. This was pre AI, of course. And just over the last 3 years, to be precise, that's when I first heard about artificial intelligence. And that stroked my curiosity. And ever since, I have been following this space. Lots of openings in knowledge for me. I learned a lot and I'm learning a lot. And that's where this Learning Twice initiative has, or rather, came to the forefront, where I thought, I always believe in this maxim that I heard when I was young, which is teaching once is learning twice. So I thought, if I have to learn AI and get better at learning AI, one easy way or one sure shot way is sharing my learnings with other people, which will reinforce the learnings much better and stronger in my head. So that's where the Learning Twice name also came into being. So I thought it's a good open forum where we can share free of any inhibitions. We are all learners here, so we can share each other's learnings, talk about AI, ideate, and show how AI is being used in the real world scenario. So that is what this whole initiative Learning Twice is all about. And I also would like to put forth an open invitation to all people here in terms of considering sharing your own learnings in the AI space, to take this initiative and make it a open forum where we can all express our learnings and opportunities that we see in the space of artificial intelligence. So that's all there is to say, about myself and Learning Twice initiative. You can also join the Learning Twice initiative on LinkedIn. I will message you or rather, I will put in the link to the group on the chat. You can join the group to be more updated about upcoming sessions that I can hold again on Saturday evenings. If you are willing to compromise on your Saturday evening party life, if that's worth it, you can please do consider joining us. And if not, at least you can share the word around to people who are interested in learning AI. So that said, I will quickly dive in to the session that I have. Today, we are going to talk primarily about visual intelligence, right? And please let me know when you can see my screen. I Shall enable the sharing now. Yeah, now.
Yeah.
Yes.
Yes.
Super.
Yes.
Okay, so yeah, learning twice. It's all about learning by teaching. So we learn AI by teaching AI, and hopefully in that context we will learn it better, and we shall be also be able to spread or make the community more AI aware. So that's the overall objective. And I also have an email that I freshly set up called learningtwice.ai@gmail.com. If you have any ideas, you can always write to me on that. And then we can continue the discussion forward. So today we are talking about visual intelligence and object identification using artificial intelligence. Like you all may have noticed in terms of how expansive or how rapidly this particular technology is progressing of late. Probably of all the of all the sense organs we humans possess, sight is probably the most exploited sense that is being evaluated by artificial intelligence. We have a lot of work that is being done in terms of developing visual algorithms and visual programs that can help us in navigating the visual space. And it's not surprising given the amount of practical use cases automating visuals can possess in terms of making our productivity and life much more simpler and easier. So today, what we will be doing is we will be building our first AI model. It is non-coding based. We won't be really needing to worry about the coding aspect of this particular domain. It's all UI driven, and anybody who has a decent computer can execute this. I will also share the tools that we can use to build your own AI model, right? Without uh, going further into that particular topic right now, I just want to whet the scope of this program by giving a small theoretical background of this visual intelligence per se. But that is going to start with this small test. If you can tell me out of these two icons that you see, water and a ball, which one would you say is more intelligent? I know the question may sound a little absurd and lopsided at the beginning, but hopefully you will see the reasoning behind this question in a couple of slides' time. But if my objective is to rest at the lowest point, which one would you say is more intelligent, water or a ball? Open for answers.
Sriharsha, some answers are posted in the chat.
Oh, is it? Okay. I am not
Yes.
looking.
Everybody has said water.
Water? Okay. Super.
Yes.
So that I I'm not getting the comments on the presentation when I put it on presentation, but you'll have to be vocal about it so that I can know that. If you have said water, then you are all right. But does anybody want to say why water is more intelligent?
Because it adjusts itself to the surroundings. It finds its way forward. It's very flexible. There is Bruce Lee, one of the famous martial artists, says that be like water because it's flexible. So that's what was the reason why I gave that as the answer.
Super. Thank you, sir. Anybody else wants to take a go?
Maybe it's in the because of the state, liquid state, right?
Okay.
Because looking at the objective, for that current objective, water is the more intelligent.
All right. We are getting there. Anybody else?
It will flow on its own way.
Okay. Okay. We are all having the answers right. So that actually derives down to the definition of intelligence. Water is intelligent for sure. But what exactly is intelligence is something that, if we understand better, can give a much more concrete way of answering that particular question. And I just happened to read a book by a person called Max Tegmark called Life 3.0, in which he defines intelligence as the ability of a system to accomplish complex goals, right? In the case of water, or rather in our objective, the goal was to reach to the lowest point. And if I put the goal of reaching to the lowest point as the objective, and I let a ball and water roll down to the lowest point, both of them would roll down, right? In that particular context, when there are no obstacles, there is not any specific challenges or complexity involved in achieving the goal. But let us say, for example, if I put a boulder in the path, right? A ball would roll down only till it hits the boulder. And beyond that, it would not have the intelligence to go beyond the boulder. On the other hand, water stream on the other side can have the intelligence to carve its way beyond the boulder, circumvent it, and go down to the lowest point. So that makes water more accomplished and more intelligent than the ball. Hope that made sense, right? So in this particular case, water is more intelligent than the ball. But now let us say suddenly there is a small elevation that comes up, in which case the water and ball, both of them, fail to navigate up the elevation to go down to the lowest point. In which case, say for example, a rat or a human who has the knowledge of the overall terrain can climb up the elevation and still go down to the lowest point, which makes them more intelligent. So intelligence in that context is something that a system has, which enables it to accomplish complex goals, where they can build and execute a strategy to accomplish that. And we all very well know, thanks to the scope of AI currently, intelligence can be both living and non-living. So this is a known fact now. We have started accepting non-living intelligence as well. So intelligence in that context can be both living and non-living. And the intelligence of each system also depends on the complexity of a goal. If I have the objective of, or the goal of, just rolling downhill when there is no obstacle, the intelligence of water and ball are more or less the same. The intelligence of water, however, is intrinsic and it is not showcased. But when I put a boulder in between and introduce a new challenge, the intelligence evolves from that obstacle that comes through. And that makes the water supersede the intelligence of the ball. So that is something that I briefly wanted to touch base upon in terms of the definition of intelligence and how intelligence can be both living and non-living, and also how intelligence is subjective or whatever, contextual in terms of the scenario that is presented. So that makes intelligence something which is uniquely derivable even outside our human brains. And in this particular case, we are dealing with computerized intelligence. So with that said, I want to start off with this other question, which is the difference between sight and vision. I'm sure we have used these words in our common language, but anybody wants to say what's the difference between sight and vision? Again, I don't have access to the chat window right now, but if you can speak that out, that will help.
Maybe it is like sight is what we see and vision is what we understand through that.
Super, that's correct. So vision is something that happens in the brain, and sight is something that happens in the eyes. So technically speaking, sight plus intelligence is what makes up vision. The challenge with sight and vision specifically is we humans, and even for that matter, more all the animals, have gotten so good at intelligence. It happens at the fraction of a second.
Yeah.
And we have gotten so good that we hardly take time to contemplate on what is actually happening when we are talking about vision. And with that in place, I want to break down vision into these three broad aspects, right? Vision first starts by detecting an object, whether it is a ball, whether it is a computer monitor, whether whatever it is. Vision first starts by detection. Once detection happens, then happens classification. By the way, detection is 100% subconscious, meaning we do not spend any conscious effort in detecting the object. It all happens subconsciously. How many times have we dodged our eyes when we have a fast flying, say maybe ball thrown at us, or maybe when insect comes, when we're riding a two-wheeler and an insect comes and falls into your eyes, even before you know it, you would have dodged and you would have closed your eyes, right? Do you think you would have had a conscious role to play when you're dodging this fast-moving object which is coming to your eyes? No, right? That is where detection comes in. The detection at that point happens so fast that it is subconscious. We detect the object and then we dodge immediately. At that point, we would not even consider to identify what it is that it is coming to hit our eyes. We just close our eyes and turn away. Classification and identification happen later. At that point in time, it is all about saving our eyes and saving ourselves from getting hurt. So we dodge. And that is what detection is all about. Detection plays a heavy role in survival as well. And that is why it is subconscious. Then comes the classification aspect of the sight. That is when vision starts to creep in. Now, classification is when you start classifying objects. Like, say, for example, this is a human, that is a ball, there goes a cat, there is a waterfall there. This is classification, where you broadly classify your objects that you see into very broad and generic categories. Here, the role of conscious and subconscious decision making is 50-50, meaning sometimes the thought process is subconscious, and sometimes it is, when I'm seeing something for the first time, it is conscious. So you have consciousness creeping in the classification stage. And finally, the identification happens when I'm trying to identify the specifics of the objects that I have seen. Say, for example, identifying one person's face against another person's face. We involve 100% conscious mind, where we identify the nuanced features of each face, or maybe they identify the nuanced features of various other objects that we want to identify, and take it into the vision aspect. So identification is 100% conscious, classification is probably 50% conscious, and detection is 0% conscious. So that's how vision works as a system. And as I said before, vision is one of the primary sense organs that we have that is being overexploited by artificial intelligence. And as I also said, that's all because of the practical applications that we have in driving useful results by automating vision. Any thoughts on this up till now?
All good. I think we can go to the next slide.
Yes, all good, Shreyas. Very, very, very good. And, your pace and the way you're narrating things is superb.
Oh, thank you, Akhilesh. Thanks. So cool. So the concept of this detection, classification, and identification can also be seen when we watch, say, maybe an infant playing blocks and shapes as they grow up. We've always seen these tools, and they've been claiming, saying that these toys will help in the cognitive ability of babies, and so on and so forth. But what is really happening in the background is it is helping these future minds to perfect the techniques involved in detecting, classifying, and identifying objects. So that is the reason why kids are always given these kind of toys to play with, and that is probably not, that definitely is not a false claim when they say that it helps in the cognitive development of a child's brain. So that is where these skills get used. So with that theory set, I will move on to the vision building aspect for our business application. So as I said, now vision involves these three domains of identifying and classifying and I am sorry, I lost my thought. Identifying, classifying, and recognition. So what we will not do in this session is we will not cover the detection part, because detection has it's a very big computer subject all by itself. And there is a lot more work that is being done, honestly, on the detection front. It is also the oldest side of computerized vision. So we have been working on detection on the computerized side for far longer than, say, identification. And detection is a much bigger topic all by itself. But what we will be talking today in today's session is classifying and identification, assuming that detection is already done at the grassroots levels by the tools that we are using. So the tools that we use will already have perfected the detection aspect of the triarchy, and what we will help it do is classify and identify, right? So that's how we will be building our AI vision model. And if you have access to a computer, that would be great, because I would also be sharing. Let me just do that right away. I will share this link. If you have computer, then you can probably download these images that I have. Just a second. I will share this link, and you can play along with me on using or rather building the AI model. Okay, I have just pinged the Google Drive. It's a very small folder. You can download it while I go through the rest of the slides, and we will use those images to build our computer model as soon as I'm done with the slides that I have. Okay, so some things to consider when we want to use building computer vision for a business case. Now, before we even build a computer vision model, it's first important to understand what are the business requirement for us to do this task, right? It's important that we understand the core concept of what is going to be achieved by us doing this vision requirement. If I have a need, what kind of a need it is? Is it just an object detection need? Like, for example, I want to count the number of vehicles that is passing through a traffic junction, right? In this particular use case, It is just about object detection and counting. I wouldn't really need to worry if it is a car, if it is a bike, if it is a cow. I don't really need to understand or worry about that. It's only to count how many vehicles pass through the traffic junction. So in which case, I may probably use the object detection and leave it at that. On the other hand, if say, for example, I want to identify how many cars and how many bikes pass through the object traffic signal, then I probably may want to consider object classification. And if I want to be even more specific and say how many Mercedes Benzes crossed this traffic junction, then probably I would go into the deepest level of object recognition. So based on the requirement, you would be better off to choose the algorithms or the architecture for using the visual architecture and algorithms. And then also you need to consider the quality of the data that is available along with how much data that you have. The quality aspect here refers to the type of images that I have. The quality aspect of it is all about the type of images that I have and the amount of images that I have. Like say, for example, I am concerned about going back to the traffic signal example. I'm concerned about the traffic that is passing through the junction, and I have installed a CCTV camera. Now, this camera works 24/7, and assume it is not spoiled in a day, but it works quite good and not made in China cameras. So in that case, I will get a lot of data. And I also need to ensure that the data needs to be of high quality. So I ensure that I capture the data in the highest resolution possible. And the lighting during nighttime is well lit so that nighttime data is not lost out. All these things, or it has infrared. All these things need to be considered when I am looking at the data availability and quality. And in case I need to install, say, for example, I'm doing this in a factory where I want to identify the products that have defects which are rolling down, and the product that rolls down the assembly line doesn't have a camera, then I need to install the camera. Where do I need to install it so that the visuals capture the defects is something that we need to consider. What resolution the images need to be zoomed in to identify the defects, that's another thing that we need to consider. So all these things need to be considered before you even embark upon the visual computer AI-driven visualization project. And then, of course, as I said before, you need to also choose the right model architecture. Say, for example, I installed a basic object detection architecture, but then my ultimate goal is to actually recognize the object. It would not work, or it would not be efficient. So I need to work it through. And I will also introduce you to the different model architectures in the next slide. Based on what you want to identify, classify, and recognize, you choose the models that are available to execute that task. And then the model must also be robust. In the sense, what it means is the models need to have fair amount of generalizability quotient in them, where you cannot hope to achieve 100% of the population represented in your visual captures. There could always be some elements of your data points that are missing in the testing set, which may not be captured in the images. So you should have a model that is fairly robust, that can generalize in case there are some data points. And you need to ensure that the lighting conditions also taken into account, say camera angles, time-bound changes, whatever it is, the model is powerful enough to generalize the model in case it encounters a data point that it has not seen before, right? And you should also be willing to accept it with a sense of error, with a error scope of accepting the error. Say, for example, if it is an airline industry which uses AI visuals to identify any defects in the machinery that involves in flying the aeroplane, then my error tolerance will be very less, as say when compared to counting the number of chocolates that are rolling down the factory assembly line, or rather the factory floor. So there, probably in terms of the chocolate, my tolerance for error could be higher, but not in the case of a aeroplane visual defect, right? So these are the things that you also need to consider before you step into the visual domain of AI augmentation. And finally, integrating this overall AI vision into an existing system where you need to see, okay, if I do this with the visual AI, what do I do with it next? Is it just about counting the number of vehicles that are passing through the traffic signal? If it is, then hook it up to a counter that just basically counts the system. Or for example, if the traffic is the traffic that is crossing through the intersection is very high, then I may want to alter the timing and the frequency of the traffic signals. Then maybe you want to hook it up to the traffic signal switch or control system that times the signals. These are all things that you need to consider and execute. So all these things need to be thought of before you build a visual AI system. So that is on the business side of the AI visual task. Right. So as I was saying in the previous slide, there are different models that help us. These are all open source models, by the way. So you can use them from a lot of platforms like, say, Hugging Face or Meta. These are all freely available. And you can use them based on the specific use cases. So I've just listed this is not a comprehensive list. But you can just you can hopefully get an idea on how these can be used across different domains and what kind of models that you could use for each of these. Say, for example, if it's a retail or an e-commerce platform, that's all about detecting the shelves, identifying shelves when a shelf is empty, or identifying when a product goes out of stock, these kind of monitoring the inventory and automating checkouts. These are the things that you usually encounter in a retail and e-commerce industry. And you could use models like YOLO and EfficientNet in this kind of space. On the other side, let's say if you have AI requirement for vision in the security and surveillance space, then it's all about identifying biomarkers like, say, facial recognition, fingerprint scans. So in these kind of cases, it would all be in terms of MTCNNs, FaceNet, OpenFace. These are all specialized in dealing with these biomarkers and mapping the facial features and characteristics. And then healthcare, you have UNet and Deep Lab. Manufacturing, you have OpenCV, YOLO. Automobiles, you have OpenPilot and YOLO again. Automotive is when you have an automated car system that is driving through, and you have in this case, this is a purely detection-based automotive AI, where it is not about identifying and classifying. It is just about detecting. If I have a sudden obstacle come in front of my vehicle, the AI algorithm should be good enough to just dodge without worrying too much or spending time in identification and classification. So in these kind of cases, you have OpenPilot and YOLO. And then finally, you even have the OCR, which is optical character recognition in document analysis, where it's all about identifying the textual information and converting them into text, machine-readable text from images. For that, you have Tesseract, OCR, and you even have YOLO there. So these are some of the AI models that you can effectively use to build all these various kind of vision models in AI. And one thing, if you notice across all these AI models, you may have noticed that I'm using YOLO quite a lot. In that, YOLO is one of the most powerful AI visual model, which has come off late, and it is available on open source for us to work on with it and fine tune it and customize it based on how we want. So it's a very useful and a very powerful tool architecture, model architecture, and it actually stands for You Only Look Once. That's what YOLO stands for. And it was introduced in 2016, and it has actually versions from 1 to version 11. What we will be using today is version 11, and it's an open source, as I said. It is called You Only Look Once because it detects objects in a single regression problem, meaning it detects and predicts the bounding boxes in one take, which makes it far more quicker and far more effective in detecting objects. And this was one of the first models that started using bounding boxes. I will tell you what these are in a bit, but the green square that you see around the text is what a bounding box is, followed by the label, which you see as the YOLO 99% on top. I just put that up. Is called the label, and that 99% is the predictability, the confidence with which it predicts a particular object. Not to worry too much about it right now. I will brief you all this in a couple of minutes, but that's what made this model so very popular, in that it's being very fast and it's used across multiple industries. And almost every year since its introduction in 2016, it has had major upgrades and updates. So it is used in a lot of industries, like we just saw in the prior slide. And it's the best of all, it's open source. So that is all YOLO for you. And before we dive into the building of the problem itself, I wanted to quickly touch base upon a very basic data, diverge a little bit into identifying the difference between the traditional programming we had in the olden days with the AI programming. So one of the primary differences in the way the traditional programming worked, in the way it generated algorithms, was we would be giving it data points and we were the ones who would give it the rules. Based on data points and rules, traditional programming algorithms would give us the answers. I mean, that's how we all learned C++, Fortran, you name it, right? We would always give it data points and we would also give it the rules to give us the answers. That was how programming was prior to the advent of artificial intelligence. But with the advent of artificial intelligence, the rules flipped, or rather, the rules changed sides. Now, what we are doing is also driven primarily by the massive upgrade in computer technology and processing power. So, what we realized is it's trivial to give rules because we don't really know the rules for everything. Now, if I ask a baby, what is the difference between the mother's face and the father's face, it would not know. Even, for example, even I would not know what is the actual difference between, say, my mother's face and a father's face. I can feel it, but I can't really substantiate in terms of a rule. I know how it is, but I don't really know what it is. So AI leverages upon that concept. And what we started doing in this scenario is we started giving it thousands of answers along with data points. And we asked the computer, now your processing power has increased. So go out and figure out the rules. So we are now giving it answers and data points for it to figure out the rules. And in turn, we use these rules to figure out answers in the future for different data points. So that's how an AI program differs from a traditional program, right? So that is one concept that I wanted to briefly touch base upon through a slight divergence before we dive into the main aspect of AI programming, which is in terms of visual annotation. Now, if you remember, I just said AI programming is all about giving it the answers, right? And in terms of visual images, artificial intelligence that uses visuals, what we need to first tell is we need to identify objects for it first. So we are giving it answers. And how are we giving it answers? Is by doing something called a visual annotation. Now, in this example, I'm just illustrating the different objects that we see in this particular image. We see a mobile phone, we see a potted plant, we see a cup of coffee, and we see a laptop. Now, for a computer, rather AI system, to identify what is what, we need to tell what is a mobile, what is a potted plant, what is a coffee cup, and what is a laptop. And we do this by doing this particular task called a visual annotation. And that visual annotation is done through what we call the bounding boxes, which I just talked about a couple of slides before when I introduced the YOLO model, right? The squares, the colored boxes that you see around each object is what we call the bounding box, which identifies each object. Now, if you see, the mobile is a purple box versus the potted plant, which is a green box, and the coffee, which is a red box, and so on. So each object is a different bounding box and is a different classification or identification. And what we do, or what we hope to do, is we provide our AI model with thousands of such images with each object identified with a visual annotation. Initially, it will be a tedious task where we have to sit and manually annotate each of these images, saying this is a computer, this is a potted plant, this is a coffee cup, so on and so forth, and then feed all the data into the computer and have it churn out the features and work out its algorithm, which is a CNN algorithm, convoluted neural network algorithm. It figures it out, it figures out the weights behind each of these, and then identifies the weights and the model architecture to correctly classify each objects and identify the objects that are presented, right? So that is what a visual annotation is all about. And with that said, I will move on to the live example of building an AI vision. And in our case, in this particular scenario, let's just keep it simple. We can build a simple AI model whose job is only to identify laptops. You can expand it later. You can even expand it to identifying coffee cups and potted plants or whatever it is. Or you can even go a step beyond and use it to identify faces from your family albums, and anything that basically uses AI vision. You can use the same technique that we're going to talk about now and use it. But in this particular case, we'll just use it to keep it simple to identify laptops. So that brings an end to our theory session. I hope it's clear until now.
Yes, Harsha.
Absolutely.
Yes, yeah.
Okay, super. Am I good to proceed with this? Has everyone downloaded the images that I just sent across?
Yeah, I have.
Okay,
I'm good.
I'm not.
Yes.
Okay, super. You can unzip the folder, and if you see those images, it's got a bunch of images that I downloaded from the internet. Cool. So one of the tools that I will be using right now is called Roboflow. The tools that we will be using are all free and nothing to worry about it. I will tell you the caveats. Nothing in this world is free completely. So, but as long as you keep that in mind, it's all free and you're good to use. You can build your own models. So the three tools that or rather two primary tools that we can use are CVAT, which is for building the visual annotations that I just talked about to annotate the images. Then we will use Roboflow to build our model. And Google Colab is an open source coding platform that you can use to code or control the model's parameters in case if you want, or if you're a little adventurous in using codes, but it is completely optional. In fact, for that matter, even CVAT for visual annotation is also optional in our specific use case, but you can use it in the future when you are not using Roboflow. Now, for this example, we are using Roboflow to build the model. And luckily, Roboflow in itself has a computer CVAT tool, which is computerized visual annotation tool, that you can use to annotate. But in the future, say for example, for whatever reason you are not using Roboflow, but you want to build a visual annotation, then you can use the CVAT. I will not spend too much time on CVAT itself because it is redundant for this, but whatever I show you in Roboflow is equally applicable for CVAT. So there is no specific extra learning that is needed on the CVAT front, but I'll just show you what a CVAT is so that you get an idea on what it is. Right? So this is CVAT. As I said, it is a tool for computerized visual annotation tool. Let me just log out and log back in. So CVAT is an open source tool again. It is free. You have some paid features that come into play only when you want some extra features, extra abilities. But for general purposes, you can use it. You can even use it to build professional full-time models. It's a very simple tool where all you do is upload it your images, and I'm just showing you an you just create a new project. You create a new project and you upload the images, and it is fairly UI driven. So there is not much new to talk about on the CVAT. I will talk about whatever is needed for CVAT by using Roboflow. So that is the reason I said CVAT doesn't really need much of a experience. You can start a new visual annotation tool using the new project in case you need to. But from here onwards, we will use Roboflow so that whatever you learn on Roboflow can be used. Let me just log out. Right? So we are on Roboflow, and you just sign in, create an account. In case you want to, you can follow along with me so that you also get an idea on how the overall workflow is. It is fairly simple, and mostly for all practical purposes is doable in a half an hour to 45 minutes time. Is anybody doing along with me, or should I progress?
I'm doing it.
I'm doing along. Yeah.
Okay.
I'm also following.
Okay. So let me know when I can proceed to the next stage.
So name your workspace there. You have to put some name.
Yeah, exactly. So we are starting with a new project, and you give a name for your project. In this case, say for example, if I want to create a simple model for identifying laptops, then that's what you give. Go by that. And annotation group is something where you give a class. It's a folder for identifying your objects. Say, for example, you can use the question mark to hover on to get a description on what an annotation group is. It says, choose this by filling the blank. I labeled all of the dash in these images. The dash can be cars, laptops, whatever it is that you want to annotate. In this case, I'm labeling all laptops. So I'll just say laptops. And I have another one, so I'm just giving laptop test, right? And the model architecture that we are using, or the project type, is object detection. You see, you can have different kinds of models that are also used. They also use the same architecture and same whatever UI and everything, but we don't really need to go there. In our specific scenario for this particular session, we can just use object detection, which is identifying objects. And you hit create a public project. Now, because this is a free project, it will put it in the open source, which shouldn't be really too much of a concern for us. But make sure you do not put any confidential or family-based pictures or anything that you don't want to be out in the public, right? So that's something that you need to be wary of. And then you create your public project. Anybody, everybody here on this page, upload page?
Yes.
Wonderful. So now what we do is we go to our pictures, and
You have to unzip that pictures.
yes, you unzip those pictures and you just drag them onto it. You drag your images onto it, and it is fairly fast. So you saw how fast it loaded on. So you have all the images that we have on that folder loaded in. Everybody here with me until now?
Yes. Yeah.
Okay. So in this particular scenario,
Yes, I'm just doing it. If you can
okay,
pick
sure.
them up.
Lalitha, while you get the system up, I also want to talk about the type of images we have, right? So if you remember the point that I made about generalization when I was talking about the system points to consider when we are building our AI model, right? So our model needs to be capable to identify false positives. When I say false positives, these are scenarios where your object can look like the object that you intended to detect, but is not actually the case. Now, in my scenario, if I want to identify, say, for example, a laptop, for a an AI system to identify what a laptop is, it also needs to identify what is not a laptop. And in those kind of cases, I need to show what is not a laptop, but looks similar to it. And in order to help it understand that, we need to give it images where there are no laptops. But if I don't give this particular image, and say, for example, tomorrow, an image of a desktop is presented, there could be a chance of the AI system wrongly identifying a computer screen and a keyboard as a laptop. So you need to give images of both positives and negatives in order to help it identify what is a false positive and a true positive. Right? So I have included an image of a desktop, and I have included obviously laptops, and the laptops will be in different orientations, in different angles, different positions. So you see how I have used it. I have laptops being used. I have laptops, again, a desktop for that matter, so that the computer more or less sees what all ways in which a laptop looks like. And again, I have some desktop images, and I also have, let me just get to that image. Just a second. Yeah, images of a laptop next to a desktop, so that the AI system will also know what is a laptop and what is a desktop, and also how they look, or how they differ when they're placed side by side. So these are all the things that you need to consider when you are choosing your sample space for the testing set, right? So you need to choose data that represents all the scenarios and covers all the possible areas where it can go wrong, right? So should I go on to the next stage, Lalit sir?
Yeah, please. Thank you.
Okay, so now we have all our images loaded in. Now, obviously nothing else but save and continue. Now what happens is it will go into the visual annotation space. Now what we do here is we start identifying objects manually to tell the AI system, look, this is a laptop, this is not a laptop, or in this case, this is a laptop. So I say start manual labeling. You can also do auto labeling, Roboflow labeling, but these are all paid premium versions. So we anyway are not interested in that for the time being. So let's start with manual labeling. And you say whom you want to, this is for team members in case you are working as a team. You want to invite team members to contribute onto the team, then you have the ability to invite multiple team members to also do this. They primarily did this because it's a huge task where your model's robustness depends upon the size of the data set. And people or organizations where they need high accuracy and predictions, they usually involve training the models based on thousands of images, and it could be overwhelming for one person to do it by themselves. So they have this feature on. But anyway, in our case, it is just good enough for us to do it, and we will be able to do it all by ourselves. So you can just say assigned to myself. And now we get into the annotation.
Harsha, I have got 62 images from that folder.
That's fine.
Yours is showing. Fine. Okay.
That's fine, sir. How many were mine showing? 32, was it?
53.
Oh, okay. Okay. Maybe I have added in a couple of images or removed a few. I moved a few actually. Yeah. It's not loading for me. Is anybody seeing the next stage, the annotate stage?
Yes,
No,
same.
not
No,
loading,
it's not
same.
loading.
Okay.
Yeah.
Click on the annotate. Click on the annotate. Looks like there is some. Click on the annotate on the left-hand side.
It says annotating.
So on the left-hand side, if you you see the menu on the left-hand side, right?
Yeah, we are seeing when we click annotate, we are saying annotating one job, and
Yeah.
it's showing 62 images and who's the labeler.
You don't see this page?
I am.
Oh,
No,
okay.
we are able to see this page, and I think.
Oh, okay. You hit the start
coming as
annotate.
annotating. Yeah, similar to what you are seeing in your
Okay.
screen.
Now do you see this?
So
If you hit start annotating,
Yes.
you see this, right?
yeah,
Okay, super. So this is the annotating window, and if you move your pointer, you will see the cross wires. This is how you draw a bounding box. Now, one important thing now that we need to keep in mind is, say, for example, this image doesn't have any laptop in it, right? So I need to classify this image and mark it as a null. You see the red circle with a hash at the bottom, the toolbar.
yeah.
So
Yeah.
I want to tell the system that this does not have any laptops in it. So I just mark this as null and move on to the next image. Now this is also a null. So I move on to the next image.
I have a laptop.
Just a quick check.
Okay, if you have a laptop, then you can hold on, sir. I'll just show you how to
Yeah.
tag the laptop. Yes, Bindu?
Yeah, sorry, Sri Harsha, Amulya here. Just a
Amulya,
quick check.
Mhm.
For example, if we mark it as null, where will we get to know that it's actually marked as null? Is there
I will tell
any?
you. I will show you
Yeah,
that.
okay.
It
Okay,
will
okay.
show you all that details in a while.
Okay, fine.
Okay, so if you have a different set of images coming through, it doesn't have a laptop, just mark them as null. And in my case, this is the second one. Now this also is null for me. Okay, let's hope. So this is the laptop. So now I just draw a bounding box around it. Now there are a couple of rules that we need to be aware of when we are defining a bounding box. Now we all know what a bounding box is. Now this is a square or a rectangle which is drawn around the object of interest, right? So I draw the rectangle around the object of interest and I annotate it by. Now, do you have the label put up or auto-populated in the label?
Yes. Yeah.
Yeah, it's done, right? That is the name that we gave in the initial text box, that if you remember. Right now,
I gave a wrong name. I gave a name of images. So can I correct it to laptop?
You can do that later, sir. But for the time being, you can just probably hit enter, and it will save that as a image for you in your case. Or if you have given it as laptop, in my case, it's laptop test. It's saving it as laptop test. Don't worry too much about the names right now, but it would be a good thing to remember in case we want to classify it or reclassify it in the future. Okay, I'll show you how to do that also later. So hit enter. Now this is saved as a laptop. You identified that part as a laptop for us. Now again, for some weird reason, all my images are coming nulls. I'm just classing it through. Now again, in this case, what I need to do is the hand is coming in front of the laptop, right? And that's fine. If you have objects obscuring your object of interest, I have other examples also that I will showcase later on. that's fine. You still go ahead and you label it or annotate it as though those objects are not there, meaning you still give it the complete scope of that particular object. Now, again, I save that as a laptop and I move on. Okay, now this is another one. And you don't need to be really particular about aligning the edges. Always ensure that you have some room left on either side, on top and on bottom of the object of interest, so that the model can differentiate it better compared to the surroundings. You should not make it a very tight bound box like this, right? Say, for example, I did this. I made it like this. Now, this is a wrong way of annotating because the model would not be able to effectively identify what differentiates it from the surroundings. So what I need to do is always be crude and free in terms of labeling it. So this is not a job for a perfectionist. It is a job for a do it kind of a guy person, right? So that's another thing that you need to keep in mind. And then again, this is another one. You don't worry about, I wanted to show one specific image. Wait a second. This image. Say, for example, here, the laptop is cut. It's not shown in full, right? So how do you think I should annotate this? The laptop is not shown in full.
Still annotate the part of the laptop.
Exactly. We annotate the laptop that is visible to us. So the laptop is visible until here. So I annotate it as much as it's visible on the photo and then save that. That's the way we do it. I'm just skipping annotating everything in interest of time, but this is another case, right? The object of interest is obscured by some other object, which is the hands in this particular case, but we still go ahead and we predict, say, for example, I don't know where the edge of the laptop is on the left-hand side. So I assume where it would, I would, based on my visual assumption, I just mark it approximately and tell it that it's the laptop. So you would have these kind of scenarios like this also. The notepad is obscuring a part of the laptop, but that's fine for us. We don't really need to worry about these kind of things. So I go ahead and annotate it. So that is how you go ahead and annotate all these images, right? Let me see if I have missed any other points that I need to. So I am deliberately included some images of a closed laptop, but I am not tagging it in order to illustrate a specific point that I would want to call out at the end of this session. Say this is another obscured one, rather a cropped one. So I just annotate it as much as I can and then leave it. So coming back to that closed laptop image, see, I'm taking it from behind. I should have an image of, this is an image of a closed laptop. Now, if I am really particular about the model identifying closed laptop images also, then I need to ensure I tag them too. But I did not get a lot of closed laptop images in my test set, so I couldn't include it, which means if I include a closed laptop image, I am deliberately introducing an error into my model because I do not have sufficient data sets, data points that represented closed laptop. So in the future, when I present this model with a closed laptop image or even an image which has something similar to a closed laptop image, there is a lot of scope for false positives. So in these kind of scenarios, when you do not have a specific data point that is not available with you in a large number, it is often better to exclude it for the time being and then build a model on the data points that you have and then revisit this model at a later point after accumulating equal amount of images of closed laptops and refine the model. So that's how you work on it. So in this case, I'm deliberately excluding tagging or annotating a closed laptop, right? So once that is done, I hit the back arrow here. Once I have done the annotation, let us say, and was it Bindu who asked me, how do I know how many I have annotated and how many I haven't?
Yes.
Yeah. So this is the tab that you can see where I have the annotations. And if I look back, I think it should also have, or maybe it will come later. This is just the annotated images. Oh, yeah, this is the annotated ones. Yeah. So these are non-annotated. You can make out the difference in the thumbnails. I am hoping. I don't know how the slight difference. Is it evident in your Zoom screens?
Yes, Sriharsha.
You can see the difference in the
Yes.
thumbnails, right? The annotated ones are
we can see
brighter,
it.
and
Yeah.
you can see that. So that's how you know how many images are annotated from your subject, from your test, and how many are still pending. And you will even get more details about it in the statistics, which I will cover in the analytics tab when I move over to that. But for the time being, here you will get a rough idea on the annotation of your images. Now, once assuming I have done all the images, annotated all the images, I just hit add 12 images to the data set. You can still go ahead and hit it. You can always come back and revisit and re-annotate and further add more images if you want to this data set. So you will not be doing anything undoable by hitting hit annotate now. So you can go ahead and add it to the data set. And when you hit on that button, you get this option which tells you to split the image set.
How to add it to the data set? I didn't get that.
Yes. You click on add 12 images. In this case, I annotated only 12. So I can say add images to the data set, and that will show you this, where it is helping you annotate or rather split the data set into different sets. Now we will have 3 sets to deal with when we are doing with an AI, any AI system, not just visual for that matter. Any AI system that you do will always have a training set, a validation test, a set, and a test set. A training set is the biggest of all the 3 on which you train your images or data points or whatever it is. So 70% of these images at random will be picked and it will be used to train my model. After my model is trained on the training set, it will then use the validation test, right? Set rather, it will use the validation set to check if the model's doing right. Now, if you remember, I would have annotated all my images. So the validation set would also have images that are identified as laptops. So what it will do, it will take an image from the validation set and it will predict using the model, and it will compare the result that it gets from the prediction with the annotation that I have provided. And based on the annotation that I have given, it would determine if this prediction is right or wrong. And that is actually a very important parameter in refining the model. And what happens is between the training and validation, the model moves back and forth multiple times, which is called an epoch. Each iteration is called an epoch. And that's another important aspect, which is called a hyperparameter that we control at a later point. Unfortunately, that comes in the coding side, which we will not test, which we will not talk about. I'll just briefly give you an overview on that. But that coding side is where you will have actual control on all these epochs and hyperparameters that you can control to improve a model's accuracy. So what happens is this is a convolutional neural network which goes back and forth between each convolutional layer to identify and define the weights for your model. And I can change how many images I want in the training and validation and test by moving these sliders. You can see how the image distribution changes at the bottom as well. So usually the norm is by default 70, 20, 20 and 10, but you can change it as per your scope or requirement accuracy. I would just leave it at default. There is not much to worry about now. And then what we do is hit the add images once we are okay with the split, training and validation split. I hit add images. Once this is done, the annotated images are added into the database. Are we good until now? Anybody needing any extra time? Is everybody doing it up till now?
Just had to step out a bit, Shreya. If you can just rewind after we annotate a few images, what did you do?
After we annotated the images, so we go back to annotation. Let me just do that. So you saw up till here?
Yes.
Okay, so I'm just assuming.
We identified a few, and a few we also tagged as false positives.
Yes, we identified the nulls. So I tag all the images that have a laptop. And I'm just doing this. This is another obscure image. I tag this, and then I go back. So for those of us who have not annotated the complete set, I told you we could always come back and finish the annotation, right? So this is how you do it. You again come back to the annotate tab on the left-hand side, and you can click on an image to continue with your annotation. So you annotate on these images, that is in the annotated tab. But once you finished your annotation, you can add your images to the data set. Right, Akhilesh?
Yes.
I hoping you saw that. And
yes,
this is the window where you define the training and validation and test set size. So 70% to 20% and 10% is the split for a training, validation, and test. I just defined what a training set and a validation set is. Basically, the model trains on the 70% of the images, and it validates its trained model on the validation set. And then eventually, I forgot to mention, test set is a set of unseen images, meaning these are images that are not a part of training and validation, which the computer, or rather the AI model, will test the images on. And it will leave the validation check for you, for you to determine if the model is working right or not. So the model will be built using the training and validation test, and you as a human will determine how good my model is based on the results that is generated from the test set. Okay, and you can alter the percentage split by just sliding the sliders across. You usually leave it and default at 70, 20, and 10. And once that is done, you hit the add images that will get added to the data pool that will eventually be used for building the model. Now, moving to the next
I think if someone wants to go more to details, that training set, that text above had more description, right? In the previous slide.
I didn't understand, Rati. What was that?
In the previous screen, where it divided it into 70, 20, and 10. If you go back to that.
Okay. Unfortunately, I'll have to tag annotated before I.
No need. Just go click the top left.
Yeah.
Okay. Here, if you go into that small question.
Yeah,
right?
yeah, exactly.
It gives some details. If you press click here, there's a lot more on click here. Yeah.
Exactly. So one good thing about Roboflow is it's so user-friendly and UI-driven. You will have good explanation provided wherever you have these helpful question marks to guide you through the process, so that you can learn more and you can also make sure you're doing it the right way. Right? So once that is done, what I do next is I move on to this is the data set that is currently sitting in the pool that will go into the model. Remember, we haven't annotated the complete set, but that is what we have that will go into the pool. Eventually, when you are up for building it, you should have all your images showing here. And this is showing you what image is used for training, what image is used for validation, and what image is used for testing. These are all by random, right? We don't really have a say in what goes to what. It just picks it by random. But if you are interested to just know what image will be used in the training model, this will be it. And what image will be used in testing, this will be it. So on and so forth, right? That's all there is to it in this particular tab. And moving on to the analytics, now this is where Amulya's question also gets answered once more, where we have a number-wise representation of how many null examples we have. We have 4 null examples, and number of images out of that is 15. So 4 out of that 15 images were null images. 11 images were tagged. Now this is the number of annotations, but remember, in our use case, specific use case, we had only 1 annotation per image because it was just 1 laptop. But say, for example, I want to annotate or rather identify a coffee mug, a potted plant, and a laptop, then I would probably be annotating 3 objects per image. So in which case, the number of annotations can be greater than 1 per image, and it can be 2, 3. So it can actually go higher. The more number of objects that you annotate, the greater this number will be. And this is another useful metric that you can, insight that you can see. Again, you can get a description on what this insight is. It shows the space in your image where objects are annotated the most. In my case, my annotations, one image had a small annotation, 1 image had a medium annotation, and 1 also had an average annotation based on whatever it says. And it's showing you an overlay of the heat map of annotations. It combines all the images that I have, and it shows the average position of all the various images that I have annotated. It's just a good way to show where your annotations are. Say, for example, all my images are annotated on the left-hand corner. Then that brings in a bias in your model that you need to avoid. So this is a good way to avoid those biases and make sure your annotations are spread across the image. Your annotations are spread across in size. They're not too small. They're not too big consistently, so that you remove all these subconscious, unconscious biases. Say, for example, I have installed a camera on my assembly line, and I capture the images of the products that are rolling down the assembly line. And it so happens all the areas of objects, and I want to identify the defects. And for whatever reason, all my defects are happening on the left-hand corner. Then that means anything that happens on, say, the right-hand corner, which could be a defect, will not be captured. Automatically, the model will be biased to thinking anything that happens outside on the right-hand corner will be fine. Only left-hand corner is of problem. So you need to avoid those kind of biases. And one way to do that is by checking the location of the annotations and the size of the annotations through these 2 graphs, right? And this is another histogram of counting how many annotations I have, how many null annotations I have, and so on and so forth. Just to give you an overview of how statistically spread out you are in terms of your training set, right? So that is all there is to do. Finally, we get to the generate model. And this is one of the most important and crucial step as well, which often gets ignored in that, because we think we have done everything there is to annotating or providing a set to the visual AI system. But there is actually one important step, which is pre-processing. I will just tell you what that is. Say, for example, if it is a photo that doesn't have the auto orientation on, that means an image can be flipped upside down. Now, in some cases, it doesn't matter when an image is upside down or straight up oriented, but in some cases, it may matter. Say, for example, I'm identifying a human face. And if I have a photo with the human face upside down, it may not be right. But say, for example, I have a photo of maybe chocolate on the assembly line. It doesn't really matter if the chocolate is flipped upside down or flipped horizontally. It doesn't matter, right? So these are the cases that you need to consider before you assign the model to work or build. So in which case you need to edit it by clicking on this. You say auto orient, you want to on, off, and these visual representations give you a good indication on what it deals about. So you can say if you want it enabled, you hit enable, apply. So auto orientation is on. If you don't want it, you can hit the cross mark to remove it. Resize, if your images are of different sizes, you need to make the images of the same size, in which case it will all be 640 by 640. My images are all, I think, 600 pixels wide. Either ways, it will stretch it. If you don't really bother about the image size, you can change that. Or if you want to edit it to a specific size, you can upload the dimensions you want it as well. So again, these are some business parameters that you need to consider before you build your AI model based on the resolution that you get from the computer the camera that you are using to capture your data points. And there are a bunch of other options also that you can choose, which could be in terms of isolating objects, which is removing the background, which could be static crop, dynamic crop. Static crop will be a set size for cropping the image. All the images will be cropped for this size. On the other hand, a dynamic crop, it uses detection algorithm to automatically identify where to crop. Or if you want to convert it to black and white, adjusting contrast, these are all specific things that you can consider based on your specific use case. In our case, in this laptop example, none of these apply. So we will cancel that and we can hit continue. And once I come to the after this, I come to the augmentation side. Now, augmentation is also another important step that will help me build on my existing data pool, right? So for example, for whatever reason, say for example, I do not have a lot of data points. I do not have a lot of images that I can use to build my model. So what augmentation does is it creates synthetic data to help me build my model and make my model more robust. And what are the steps that you have in augmentation? Is you can have an image which is flipped upside down, rotated 90 degrees, crop. Again, these are subjective parameters that you need to consider on a use case basis. Say, for example, if it doesn't make sense for my data to be flipped, then you would not choose flip. If it doesn't matter if I am having a rotated image, then I choose rotated image. It depends on how you want to do it. And each time, say, for example, it doesn't matter if I'm having a flipped image. If I say I want a flip image, each image will become two images. So this image is the original image is one image and its horizontally flipped image is another image. So that will become two images. And I have an option to choose horizontal and vertical. So it will become three images. So on and so forth. If I uncheck that, it will be just one. If it is horizontal, it becomes two. If it is vertical, it becomes three. In our case, vertical may not really be applicable because there will be no images of upside down laptops. So I may not choose that and I just say horizontal. So what this would make is it would double my data set and it would apply a doubling factor for my image set, right? That is the one of the augmentation benefits of augmentation. And finally, once I'm done with augmentation, before I go, any questions until now? Everybody doing this with me or?
Absolutely, very, very good, Shreyas. So far, I'm able to follow and I'm able to do.
Super. Thanks, Akhilesh. Okay, now is the final part in the set variation size. Here, because we have tagged only a few images, our data set will be, we had one pre-processing step that added 1x and then 2x in the horizontal augmentation. So our data from the annotated images has come to 3x, which will be 35 images. So that is how your data will increase based on each augmentation and pre-processing step. So you can artificially or synthetically increase your data pool, right? So once we are here, all the way up till come up till here, you can just now hit create and give it a couple of seconds, and we land on this page. Don't hit any button yet, but everybody on this page with me?
Yes.
Yeah.
Okay, super. Now, if you look at it, at the bottom, you would have this available credits. I think it will be 3 credits for each one of you, right? Nobody has used Roboflow before. So I'm guessing everybody would have 3 credits.
Yes.
That means
That's
you will.
That's right. Yeah, I've also got 3.
Yeah. So that means you have 3 free credits that you can use to build a model. I will also tell you how you can bypass this in a bit. But when I hit the train with Roboflow purple button, it consumes that credit. 1 credit is consumed, and it will generate your model based on a visualized UI base, and it will generate your model. I will not hit that because I have just 1 credit left and I'm saving it for I don't know what. But I would not do that. And I would suggest you also don't hit it right now, but I will just walk you through what you can expect without actually going through the whole process. If you want to build your model properly, I would recommend you go back to the annotation set, finish your annotations and finish your augmentations, and then hit the train with Roboflow. Till then, you are better off not going through with that. But in case, assuming we have done everything, I will just show you what we can use with this. So when you hit on that, you will be presented this option, which is basically choosing the model architecture. Honestly, I haven't used any of the Roboflow architecture or YOLO NAS. I have built my model on YOLO V11. So you just say YOLO V11 and you continue. And this is where you hit continue in the next page. Fast is the default. Accurate requires us to upgrade. But for the free version, you hit on fast. And when you hit continue, that is when the model will start to build. And that is when 1 credit will be consumed. So I will not go beyond the continue button, but I'll just close this. And this usually, based on what I had done using the similar data set in my earlier credit that I consumed, it took me about 15 to 20 minutes to build that model, right? So it will run its magic in the background, and after 50 minutes, you will have a model. I will show you that model as well. But before I go to that model, I quickly want to show you on this custom train and upload. This is a way in which you can build the model without consuming a credit. If you remember, I told you there is a workaround for that, but the only catch here is it is a coded version. So you will need to be brave enough to work on TensorFlow on Google Colab. That is the reason I also told Colab is a optional in the beginning slide, where you use it as a optional in case you are comfortable using with it. You use the model. You have different YOLO models that you can choose. I just choose YOLO V11 because that's the latest and the most accurate. And then you hit get snippet, and it will create a copy coded snippet. This is just some Python snippet that gets generated. It will have a UPI key, user identifying key that will be unique to your login, which is masked out in this particular video, which you needed to use. But when you click on this button, copy snippet, and open YOLO V11 notebook, it opens on Google Colab. I will not be going into the Colab version because this is a behemoth in itself. Initially, you have a whole bunch of instructions on how to use this, along with all the statistics and the different codes and examples that they have given to help it make it easier. It is actually easy. You can definitely do it. And if you remember, we said in that purple button, copy snippet and launch, right? If you remember that, that copy snippet needs to be pasted. I'll show you where, just a second. Yeah, this one. You need to paste that copy snippet here. Right? You paste that copy snippet here and then you run Colab. It should build your model. But I am not going to do that because this is a different behemoth in on itself. But you can go through the content, or maybe I can host a separate session if you are interested to work through this. But for this practical session, we can close this for now and be happy with training the model on the UI interface, right? So assuming we all build the model using this interface until now, we just need to exit out. You will have your model in this visualize tab. I do not have that here because I haven't run the model yet, but I have another model which I built on the same data. So I will go to that project in order to show you how the visualize and deployment tabs work. So everybody okay with me for that?
Yes.
Yes.
Okay.
Oh, sorry.
Yes.
Okay. So I'll just move over to the other model that I had built. So this is the one we just created now, laptop test. This is the one that I have run. So you notice I have 1 credit. The 2 credits were used for this laptop detection and computer desk object detection. I will open laptop detection. And we exited that particular model at this stage. When your model is built, when it is being built, you will have a lot of updates that are coming here. And when that is built, you will have a QR model as well, QR code as well. Now, if you have your smartphones handy, you can take your smartphones and scan this QR. Just a fun project. Scan this and point enable camera on your phone. When you scan that, it will say enable, it will ask you if you want to enable camera. You say enable camera and point it at your laptop. Point it onto your laptop and see the magic. Let me know when it works.
It says loading model weights.
Okay, just give it a couple of seconds. When it asks you to enable camera, you enable camera and then point it towards the laptop.
So it is able to detect my laptop.
Yeah, mine too. It's
Super,
cool.
super.
Mine too.
Yeah, so that
When I'm
is
trying
how.
to do it with the half of the laptop, then it is not. Only full laptop
Yes,
it is able to
yes,
detect.
because we trained it on less data. So this is a very good point. Was it Lalit sir who told me that?
It's Samir.
Samir, hi Samir. Yeah. So that's a
Hi.
very good point you told. One reason why that is not working is because in our sample, in our test sample, we have less examples of a half laptop image. So now you build this model, you automatically have realized where its shortfall is. If you close your laptop and do the same exercise again, I mean, don't close it now, you lose the session. But if you close it and do it again, it will not work either because we did not train it on images with closed laptops. So it will not be able to detect that. So these are the outliers that you need to be aware of, which are the shortcomings of your model. So when I build a computer vision model, not only should I know what are its strengths, but I also need to know what are its weaknesses and in what scenarios the model will not work, so that I am vigilant on a human side to enable those failures are tackled not by AI, but rather by humans. So that is one important thing that we need to keep in mind. Just because I have an AI system enabled doesn't mean that I'm completely off guard. Right? So that was a very valid point, Samir. Thanks for bringing that up. And this is your version of the model, and you can further move on to visualize your model. Say, for example, I want to, this is in the visualize tab at the bottom. Say, for example, I want to paste or rather take an image which I have, which the model hasn't seen until now, and use it to identify, see if it identifies a laptop. Let me just go there. I'll put in a new image. Yeah. I will say take this, right? Now let's see, I have uploaded this image from the thing and you see it's already detected. Can you see that?
Yes,
Yeah.
we can see it here.
Yeah. So it is detected my laptop with a 93% accuracy. That's the number 93% next to it. And that label that we have given is what we, oh yeah, I need to remember to show you how to change the label. I will show that later on in a bit. But that's how your model works. And one important thing that I also want to talk about is the confidence level and the overlap threshold. Now, these are the two hyper parameters that we can control from this UI interface. You will have a lot more control when you're dealing with it on the coded version in terms of increasing more hyperparameters or controlling hyperparameters. But the most important ones are given here, which is the confidence threshold and overlap threshold. To illustrate what it does, let me just increase the play around with these sliders to see what happens. Can you see the bounding box? You can see the bounding box clearly, right? Across my test image.
Yeah.
Yes.
You can see that, right? So now let me just increase the threshold. See what happened. It disappeared, right?
Yep.
Yeah. Can anybody take a guess why that disappeared?
Because it is only sure 93% that it's a laptop. It's not to sure 99% that it is a laptop.
Exactly. That's perfect. That's the correct answer, Samir, because my slider is currently at 99% and the model was showing it at 93%. So until 93%, the laptop will show. If I go 1% above to 94%, the confidence threshold is crossed and it is not showing me that. So one important thing I need to keep in mind is when I am evaluating the model, what should be or rather building the model, what should be my confidence level? What should be my confidence threshold? I will be getting a lot of false positives and a lot of true positives based on how I set the confidence threshold. Right? So keeping it at, say, acceptable. So for example, if I'm in an airline industry, going back to that aeroplane example I talked, the confidence threshold there has to be very high. I should probably keep it at 99, 95. I don't know what those guys keep as a standard, but they need to keep it at that level and then execute those models. On the other hand, if I'm in a chocolate factory, I can probably keep it at 50%. So that's how you play with these hyperparameters based on your industry to accept the error tolerance for your model, right? That's one thing. And another thing, in our case, overlap threshold doesn't really matter because we are just detecting one object. But overlap threshold comes into play when you're detecting multiple objects. Say, for example, I was detecting a laptop and a desktop monitor. Then the overlap threshold is how much confident that I am that the front object is obscuring the back object. And the front object is a laptop and the back object is a desktop monitor. If you want, you can add those other annotations and then play with the overlap threshold. But in our case, it won't work in this case, right? So that's one thing. And the other thing that I want to talk about is the map and precision scores and the recall scores. So you have these helpful question marks again that define what each of these metric is. This basically defines how accurate and how robust your model is by hovering over those points. The most important is obviously the map, which means mean average precision. It basically says how accurate your model is based on its comparison with the validation test that we provided. If you remember, we split our data into training and validation and testing, right? So the map score is derived by comparing the predicted values with the validation test and seeing how much of the score matched with the score, labels presented in the validation side. So 85% of my validation data matched with the annotations I had given. So that is roughly what it is. So, and if I scroll down, I think I was here. No, I'm sorry. If I scroll down in the version, I actually see training graphs as well, which again illustrates how my map score has been varying with each epoch. The numbers on the x-axis is an epoch. An epoch, as I said before, is an iteration between different one forward new progression between the validation and the training. So my model here in this case had close to around 287 epochs. So that's how many times it went back and forth, adjusting the weights. And with each epoch, it adjusted the weights in such a way that the precision kept changing, right? So that's how it is. And it could have probably stopped here where the map score was 91.8. But in this visual UI, we don't have control of telling when to stop it. There is in the coded version option called patience that you can use to stop the epochs when a score map score reaches its maxima and doesn't improve beyond a specific side, and it will stop the model. In our case, I think I had set, I don't really remember, but I had not set a set condition for the epoch, so it just ran free. And I guess you will also have that same scenario, but just let it run. That doesn't matter in our case, because you cannot control it in the UI based version as it is. But that's one way in which you can use the map score to determine how accurate your model is. And the other one is box loss and class loss. Box loss is how accurate your bounding boxes are in defining the object of interest. If the bounding box is completely covering the object of interest or if it is moving beyond. Again, it uses it based on the validation test. And class loss is, say, for example, I have 4 classes, which is laptop, coffee mug, and a desktop monitor. Am I identifying? It's not good if I identify a laptop monitor as a desktop monitor. It is wrong. And the class is, the objects are identified right. The bounding boxes may be bounding the laptop and the desktop monitor correctly, but the classes are not right. So in which case I have a loss in the class, right? And that is the metric that showcased in class loss. And an object loss is when it completely fails to detect that object itself. It doesn't detect the object. And that's when you have a object loss. So in my case, for this particular model, my precision score is 85%. And my box loss is 1.23. Here, the lower the score, the better. And class loss is 1.3. And object loss is 1.85. So that's how I evaluate. And that's the overall visualization of building your, overall exercise for building your first visual model. And I quickly want to put a closure to this by giving you one additional point. But before I go there, do we have anything on this until now? I'll take another 5 minutes max, tops.
Sriharsha, when I use the camera, when I used the scanner and then pointed to my camera, that sort of didn't work. I don't know why. It was showing some blue lines running across, but it didn't go forward. Did I miss something?
Which camera, sir? Your phone camera?
Phone camera. After I do the scan of the QR code, which you
right
did,
right,
then it told me to enable camera, and
yes,
I pointed it at my laptop,
okay,
but it didn't detect it. I don't know why. I mean,
maybe you want to try it again, scan it again.
Yeah. Can you show?
I will do it.
It says demo.roboflow.com, right?
Yes.
tap shutter button to open website. Yeah. So it's saying loading model info, loading model weights.
Give it a couple of seconds. It should load it up.
Yeah, now it says model laptop detection. Use your webcam to test this. And do I press on turn on camera?
Yes, yes.
So it's the camera is turned on. Now I point it to my laptop, right?
Yeah, yeah. And it will
So
show
I
you.
see it shows me some blue lines and then they vanish away.
Okay. Did anybody else have that issue? Or
Yeah, I also had that issue. I also have my laptop on the table that is stacked right next to a set of 4, 5 like vertical boxes, like drawers, right? So it actually recognized the drawer more than this one, the vertical one, than the laptop.
Yeah, even I have that issue, Shriyasha. So I'm pointing to the laptop that I'm using now for the session. It showed that box and then it quickly went off. And that box came in a corner of the screen.
Okay. Not sure. Maybe because too many people are accessing that model, maybe it is jittering. Could be because of overloading that. This is the free model at the, for all fairness. So I'm having my doubts on the capability. Maybe I will anyway be sharing this QR along with the PDF of this presentation. So you can use that and try it maybe at a different time to see if it works right.
Thanks.
Yeah, and another thing is this QR ability will come with the YOLO V11 model. It may not come in an earlier model of YOLO. So if you want this QR feature, then you're better off sticking with the YOLO V11. Okay. Fine. So moving on, coming to the closure. So I said initially that there were 3 aspects of vision, right? Detection, classification, and identification. Well, I was wrong in that there's not actually 3, but just to make the class a little more structured, I use that liberty. Actually, there are 4. And to illustrate that, check this out. We have this basic intuition in all of us, right? What do we know as soon as we see this image? We are almost put at unease, right? In terms of like, geez, shit, the cup's gonna tip.
Yeah.
Yeah. So that's the 4th part. What is that 4th part? It is prediction. So a lot of work has been done in detection, classification, and identification. That's for sure. But also now, with all the advancements in the computer hardware and architecture, we are now moving into the prediction phase, where a computer visual system, AI vision, is also capable of forecasting and predicting. If you noticed all until now, what we have been just doing is identifying and classifying. We never went into the domain of predicting what something is or what something can happen. And how this can come into the scope is, say, for example, I have an autonomous car driving in front of me. A autonomous car driving, and there is a haphazard or rather some object that comes in front. So you need to have a system that is capable of predicting its trajectory and dodging it. Or maybe if you have a set of images in a medical scan, that needs to be extrapolated to see if that can indicate or predict to a future health forecast that could be of concern to the person. There are a lot of use cases in these kind of scenarios, right? So that is actually the holy grail right now for vision, vision-based AI models. And a lot of work is being done in predicting how visuals are. This is more, of course, heavily dependent on video too, but it doesn't preclude it from still images. But it is still nonetheless the holy grail. There are a lot of work is being done, not just on kinetics, physics, trajectory motion, 3D motion. A lot of things are being done in this space to enable that prediction side of vision as well, to complete the 4 prongs of the vision-based system. So that said, I come to an end of this session, and hopefully it was useful, and I will get to have you experiment and build your own AI vision models, and I'd love to see how they all shape out. Anything before we close for the evening?
Thank you very much, Shreyasha. This is wonderful.
Sorry. Siyasha, fantastic session. I'm loving
Thanks,
each
sir.
bit of it.
Thank you, sir.
You explained it so nice that a layman could understand this so well. And thank you for doing all the hard work and sharing this with us. You are my guru today. Thank you.
Honored, sir. Honored. I am privileged to have that come from you.
Very
Beautifully.
well put through slides. The theory, how it, first you put the theory, then the practical. It was like very relatable and very nicely you put it together. Very nice. Very good.
Thanks, Bindu.
Thank you so
Beautifully
much,
structured,
Srishasha. It's
Shreyasha.
really good, and it's a new experience to me and all, because we were in a different platform and trying to get into a new platform out of theory and trying to see something on screen. That's really good, and it's an enjoyable session. And thanks a lot for your efforts.
Thank you, Sudhakar. Before we all drop off, I would like to share a quick poll, Lalit sir style. Also wanted to invite you all, like I said in the beginning, to please consider sharing your learnings with us on the Learning Twice platform, which will help us take this community of AI learning forward, because teaching once is like learning twice. Now I'm sure I will be seeing Roboflow in my sleep too, thanks to this session. But please do consider, and I would love to hear how your models fared and what all adventures you did with these Roboflows to build your own models. By the way, I'm hoping you all saw the polls. Did you get the poll?
Yeah.
Okay, super. If you are interested, you have any AI learnings, please do say yes, and I can reach out to you using your email, if you don't mind, and we can take that offline.
Thank you, Shreyasha. Wonderful session.
Thank
Thanks,
you.
Thank you,
Shreyasha.
Sriyasha. Very
you.
good
Very
session.
nice.
Thank you so much.
Thank you all.
Thank you, Sriyasha.
Thank
Bye.
you.
Sriyasha, thank you very much. Wonderful session. Enjoy.
Thank you, Murthy sir. Thank you.
Bye.
Thanks a lot.
Bye. Thanks, Revati. Bye.
Bye.
Bye, Harsh. Thank you so much.
Bye, Lango. Thanks.